Assalamu alaikum. Hello everyone. Today I am going to start our new lesson which is relevant with power electronics project, as we know that everyone needs the final year project based on thesis or regular project. In this tutorial part of the video, I will now going to show you some thesis topics about power electronics. Basically, as some power electronics, we are working now with inverter. You everyone know that inverter is a part of renewable energy which can give us the output of sinusoidal platform as respect to DC. So now I am going to start our lesson. In this lecture, I am going to show you some thesis which is about 5-level inverter. This is a paper from where I am going to start this project. This is the circuit and output waveform of 5-level inverter. You are seen here that this is the 5-level inverter output. Basically, there are different types and qualities of 5-level inverter which we can produce. There are some method half high, feed forward, half equal method, and equal phase. So today I am going to show you how to simulate them, and after simulation you can find out the result. After find the result, you can go to the circuit diagram process and you complete your project. So as you know that this is the 5-level inverter. This part is known as half cycle, positive half cycle, and this part is the negative half cycle, which is symmetrical but the direction is negative. And this is the replication of positive half cycle. So in this part, we are completely demonstrate about this project. So first of all, we have to know how about the inverter circuit works and what does it mean. So in this process, I design here a circuit diagram where two different voltage source V1 and V2 you are seeing. If some voltage source will active, then it as if the positive half cycle first part, and after activation the second voltage source you will get the top of the positive half cycle wave shape. There are two parts. In this case, I am shows here the V2 level for top of the positive half cycle, and V1 is the first portion of positive half cycle. Here S2, S3 and S4, S5 are designed for H-bridge system which will generate the replication of positive half cycle and negative half cycle. So first of all, we have to find out the angle calculation. Basically, when the pulse will activated, it is calculated by using some calculation method which is given here. There are some method is applied here, that equal phase method. This is the equation. Here you will put the value of L is the number of level. If this inverter is 5 level, then you apply 5. L is equal 5. If this is 7 level inverter, then you apply 7, and 9 level if you apply 9. Half equal phase. Half equal phase is quite same as equal phase method, but some of the sense are applied here. This is the equation here. You can use also this. And this is the half high method. Half high method is quite complex, but it will gives us more proper out. And at last, feed forward method. So today I am going to show you about half high method. If you can simulate using half high method, you can also apply your necessary part. So for half high method, The angle will be calculated here, but you can also calculate them by using that equation. If the result is mentioned here, that's why I am not going to show you the activation process. So now here I develop a MATLAB code to find the output and voltage angle. So I am going to put here the equations output. Here is 14.477. I apply here 14.477 and value of alpha 2 is 48.590. And now I run this equation and we got some value that the value of S1 will be activated for 41.9572% and S2 will be active for 23.0056%. This value is necessary for us. Now we are going to open our simulating part where we can simulate this software and going to active some parameter. So first of all, we need to voltage source. So we are putting this. Here is DC voltage, and that's why we are copy this voltage source. Now we need an IGBT or MOSFET S1. So we are putting this S1. Here is our IGBT. And we need also 4 IGBTs to develop the H bridge, which are shown in here S2, S3 or S4, S5 and the load resistor, also a diode. Now I am putting them together. A diode and 4 IGBT also, and a resistor. Now connect all of this according to the circuit diagram. So now we are connecting them. This is the part of H bridge. Now complete the connection of H bridge and resistor according to the circuit diagram shown before. Now connect this diode here. Okay. And here, this is the most important part, that apply pulse generator function. So we are applying pulse generator and we also need OR gate. Okay. Basically, you have to pulse in active to the part of S2, S3 at the same position, turn on, and you have to apply S4 and S5 the same pulse to activate the negative direction at the same time. So basically S2 and S3 gate will be short through a pulse generator, and S4 and S5 the gate terminal will be short through a gate pulse. Also S1 will be put at another pulse. So I am applying here the S2 and S3 will be activated for same pulse. S3 and S4 will be activated for another or same pulse. We also need another pulse generator. Okay, now we need to put value here. Now this is the main part here. We have to put the period or second, which is 0.02, and our pulse with percentage of period, which will be acid from here. We know that the S1 will be activated for 41.9572%, which is mentioned here. 41 point, I forgot, 9572. 9572, and phase delay will be started from this part. 8.80, 8.0428. Okay, and this is the same but replicated function. That's why I'm copying this to get easily the output here. And this will be started from this part, 0.0108. Okay, our termination of first switch has been completed, and now we need to active the pulse here. So we also put this value here, 0.02. Pulse width percentage, the value will be get it from here, 0.0027, 0.0027. This is the value of phase delay, and the activation period is 23.0056. 23.0056. We also need another pulse for negative half cycle, and both pulse will be added by a OR gate. The value will be same, just add here a 1 to 7. Okay, our system is 100% ready. Now we simulate this function and we'll see that what is going to happen here. We also need a voltage measurement and a scope. Apply voltage measurement to the part of the resistor to measurement the voltage, and apply scope to see the actual output getting from the MOSFET or IGBT. This is the output of high level inverter. You can see here that this is the positive half cycle, here 0 to 100. This is the first voltage level, and from 100 to 200 this is the second voltage level, and this level will be replicated at the negative side, and this is the output finally achieved. So this is the process of simulation of multi-level inverter using cascade voltage source method. You can use this method to develop different types of output and different types of voltage gain level of multi-level inverter. So no more today. Use these policies for better option. But here I apply a code. This is not just a big deal. You can also calculate it through different calculation method. This is I developed just because for easy calculation. Otherwise, this calculation will be some longer and our video will be more. So no more today. If you have any question, comment me. My Facebook profile will be given in description box. You can also knock me there or mail me there. On the other hand, I am going to show you some different part of the power electronics research topic here. So continue watch my video. Thank you everyone.